All right. Good morning, everyone. Now we are going to discuss this speed test number 2 today. I gave you the time to discuss this. I gave you the time to write answers to this speed test number 2 in the morning. Now we are going to discuss this one. This test is regarding discuss this speed test number 2. I gave you the right. So this test is regarding inorganic chemistry. Right. It's regarding inorganic chemistry, and there are two questions. First question is it is regarding the determination of a metal. Okay, and the second question it is regarding the qualitative cation analysis. Right. Now let's start discussion. Right. I think we can start from the question number 1. Speed test number 2, question number 1. Right. Question number 1. A metal chloride A and its products are given below. Right. Now A has been reacted with sodium hydroxide and hydrogen peroxide to give a yellow solution. So whenever I am reading this statement, I understand that A has to be chromium because chromium is the only element that reacts with sodium hydroxide or base in the basic medium with hydrogen peroxide to give a yellow color solution, that is chromate, right? CrO4 2 minus. So that yellow solution B should be containing CrO4 2 minus ions. Since we have used sodium hydroxide, it has to be sodium chromate, Na2CrO4, right? So let's identify this one by one. Right. Now, whenever you are given a question like this, the important thing is you have to draw a flow chart. A quick flow chart has to be drawn. Have you done these questions before? Questions like this. Now, since we are doing the revision, you might have done these type of questions. Did you ever draw a flow chart? No, you might have. Yes. If you draw a flow chart, then it will be easy. Now it says A reacts with A in the presence of sodium hydroxide with H2O2. It gives a substance B, which is yellow. Then that B solution with H2SO4 will turn into C, which is orange. Right? It will turn into orange. Then that orange color one with potassium chloride and conch sulfuric acid it will give a red brown color vapor, that is D. Now D is a gas, it's a vapor, it's red brown in color. Okay. Then C also reacts with ammonia. This C, it reacts with ammonia and gives E. Right. C reacts with ammonia in the presence of HCl and it gives E. Then E is thermally decomposed into F, G and H2O, F, H2O and G. F plus H2O and G, it is said that G is a green colored powder. So G is a solid which is green in color. Then F with magnesium, it gives H. And H with water, it gives I and ammonia. No? It has to be NH3. Yes, it has to be NH3. There's a typo, it has given as NH2, it has to be NH3. Yeah? Right. So this is the flow chart. Now, with the help of this information, we can identify each of these substances given. Now, if you have drawn the flow chart like this, now we don't need the question. We can proceed with the flow chart. Right. So let's see. So I'm going to somewhat distance so that I can see all the things. Right. Now we have A. A with sodium hydroxide and H2O2 gives a B, that is yellow colored solution. Then B, once it is acidified, it turns into C, that is orange in color. Okay. Is it difficult for you? Right. So then we have C. Then C with ammonia, it will be giving some other compound, E. Then E, once thermally decomposed, gives FH2O and G, which is a green color substance. Then C with KCl and concentrated sulfuric acid, it gives a red-brown color vapor. Those are the information given. Now, whenever we are reading the first sentence, I realize that A has to be some chromium compound, right? That's why with sodium hydroxide and H2O2, it gives a yellow substance. So yellow substance has to be the chromate. CrO4 2-. So once CrO4 2- is acidified, it turns into dichromate. No? The reaction is there. CrO4 2- in the presence of H plus turns into Cr2O7 2-. And Cr2O7 2- in the presence of OH-, it turns back into chromate. So it's a reversible reaction like this. This is yellow in color, this is orange in color. If you can't remember, you can write it in anything, in anywhere. That means I think you have notebooks and some papers as well. So you can write them, note them down, the important things. Right. So therefore, chromate is this one. Then C has to be this one, Cr2O7 2-. Right. Now dichromate with ammonia, it gives E. E is ammonium dichromate. NH4 twice, Cr2O7. Ammonium dichromate decomposes to give ammonia gas, water, and Cr2O3 solid, that is the green color solid. Okay, so it has water and ammonia as the gas. Ammonia with magnesium, it will produce, sorry, not ammonia, sorry, N2. The gas is N2. That means once ammonium dichromate is thermally decomposed, it gives chromium oxide, water, and nitrogen gas. Nitrogen gas with magnesium, once it is heated, it will produce magnesium nitride, Mg3N2 solid. Once it reacts with water, it gives magnesium hydroxide and ammonia. So I has to be magnesium hydroxide. Is it clear? So likewise, we have identified all the substances are right. Now there's one thing here. Dichromate with potassium chloride and concentrated sulfuric acid, it gives a red-brown vapor. We call it chromyl chloride. CrO2 Cl2. Right. CrO2 Cl2, it is a red-brown color vapor. Is it clear? Okay. So if you have drawn a sketch like this, it will be easy. Now in the question, it says that this is a chloride, no? The metal chloride of A. So A has to be CrCl3, chromium chloride. Okay. Now this is the sketch that you have to draw in your rough worksheets in the exam. In the exam, if you are given a question like this, you are given rough worksheets. So you can quickly sketch this in a rough worksheet and find the answers. Then you have to write the particular answers in the answer script. Is it clear? Right. Now we have finished identifying the particular species from A to I. You can write the answer. Right. So give the chemical formula for A, B, C, D, E, F, G, H, and I. So you can write these chemical formulae. Then let's move on to the second question. Give the balanced chemical equations for A, E, and G. Simple. A, that is the formation of the yellow solution, this one. E is the thermal decomposition of this one. G is the reaction of H with H2O, this one. Right. So you have to give the balanced chemical equations for that. Okay, can I erase this one? Now A is CrCl3, chromium chloride, with sodium hydroxide and H2O2. It gives sodium chromate, Na2 CrO4 aqueous, right? Na2 CrO4 aqueous. So let's balance it. Now we have chlorine here. So sodium with chlorine, it will produce sodium chloride. Right, sodium chloride. And to balance, we have to put water. Once we balance, it will become 2 chromium chloride, 10 sodium hydroxide, and 3 H2O2. It gives 2 sodium chromate, 6 sodium chloride, and 8 H2. Now it is balanced. Okay. I'm not going to teach you the balancing part over here because balancing is something else. We will be learning balancing later. Then simple E, the thermal decomposition of ammonium dichromate. NH4 twice, Cr2O7. It is thermally decomposed to give Cr2O3 solid, N2 gas, and H2O liquid. Right? So let's balance this. We can put 4H2. All the others are balanced. 2 nitrogens, okay. 2 chromiums, yes. 4H2O, it's balanced. Other one is G. Mg3N2 with water. It will give magnesium hydroxide and ammonia. Okay, let's balance. 3 magnesium is there. 3 magnesium hydroxide and 2 ammonia. That's how we answer that question. Right? Is it clear? Now, in that question, it's a good question. There are so many important things regarding chromium. Chromium ගැන වැදගත් දේවල් ටිකක් අපි කතා කරා reactions ටික. Now you better go home and refer about chromium. I think you have the notes. Since it's a revision, now you might have notes. If you don't have, just let me know. Then you can refer about chromium with the help of this question as well. Don't worry, we'll be discussing a series of another questions regarding inorganic chemistry as well. I know that this is one of the most difficult parts for the chemistry students. Not difficult, one of the most hated subject areas in chemistry. Yes, I don't know what's wrong with you. Even I was a student, I hated it. Yes, inorganic chemistry. It was the most hated part. Right. Then the second question is with regard to the qualitative cation analysis. Qualitative cation analysis. Right. If you can't remember the qualitative cation analysis, so take the sheet of paper that I have given to you today regarding the qualitative cation analysis. Right. There's a small note regarding the cation analysis. I'm not going to read this out because you can refer this. Now let's apply this. Huh? Okay, can I erase this one? Right. So there are the qualitative cation analysis. There are usually there are 6 groups of analysis, but in A-level syllabus, current A-level syllabus, we will be focusing mainly up to 5. Right. But I have mentioned the sixth one as well, that is regarding the identification of magnesium. Right? It's okay. The first one is precipitation of the group 1 cations. Do you know the principle behind this cation analysis? Can you remember? No. Right. Now, cation analysis means, though it is an inorganic chemistry analysis technique, here it is regarding the KSP, that means solubility product. We know that certain solids, they are soluble in water. Some are not soluble, insoluble in water. That means those are called the precipitates, right? So almost all the precipitates, they dissolve to some extent in water until we surpass the solubility product value. Is it clear? That means if the concentrations of the two ions, right, if the multiple of the concentrations of the two ions exceeds the KSP value, then only it starts to precipitate. For example, let's take silver chloride. Silver chloride, is it a precipitate or aqueous solution? No, usually silver chloride is a white color precipitate. Yes. If we take a test tube, and to this we are going to take some silver nitrate. And we are going to add hydrochloric acid into this. What will happen? Now let's assume we have added hydrochloric acid up to this one, and this is going to be a mixture. Then it will form a white precipitate of silver chloride at the bottom. And there will be an aqueous solution. But in this aqueous solution, this is mainly water. There are some Ag plus and Cl minus ions present. Okay. Then with those Ag plus and Cl minus ions, with this silver chloride precipitate is there. So it will have a dynamic equilibrium like this. There will be a dynamic equilibrium of silver chloride with Ag plus and Cl minus. Is it clear? Now for this, we can write the KSP expression. KSP equals to Ag plus aqueous concentration into Cl minus aqueous concentration. Right. Right. Now that KSP value is it's a constant value, right? And if we do not equalize into KSP value, this Ag plus into Cl minus concentrations, it's called the ionic product of this solution, right? If that ionic product value is lesser than the KSP value of silver chloride, then it is not going to be precipitated. Then it is a solution, right? If Ag plus and Cl minus concentration values ionic product is equal to KSP, then that is the point where the solution is saturated. Right? It's the point where the solution is saturated. Whenever we are adding a single drop of another, either Ag plus or Cl minus, it starts precipitating. Right? So if the ionic product is greater than the KSP value, then only a precipitate is formed. Is it clear? Right. Now here this cation analysis is based on that. Right. Now several cations, they will produce precipitates of different colors and different properties. Right. We are maintaining, that means we are regulating the conditions. Right. So while regulating those conditions, we can precipitate some of the metal cations only. So that is the principle based on this qualitative cation analysis. So in the group 1 cation analysis, we are precipitating 3 precipitates. What are they? In the group 1 analysis, silver, lead, and mercury. At least you can refer to the butte. It's okay. I have given you to refer, right? So it is silver, lead, and mercury. They will precipitate as their chlorides, and all 3 are white precipitates. Then to precipitate them, we are adding dilute hydrochloric acid, right? Is it clear? So there are some other chloride precipitates as well, right? But here we are regulating our conditions so that with that treatment, only the silver, lead, and mercury will be precipitated as their chlorides. Is it clear? So then we can precipitate all of those metal ions, and then we can take the
ඇහෙන්නේ සර්.
Right. So what does that mean? That means there are no group 1 cations present. No? If there were group 1 cations, silver, lead, and mercury, either silver, lead, and mercury is present, then there will be a white precipitate. Since there is no white precipitate, that means we can conclude that there are no silver, lead, or mercury ions present. Okay, you can write the answer with me. Now identify A and B by explaining each conclusion. So we have to explain of each of these observations. First one, we can say the group 1 cations are not present. The group 1 cations are not present because no precipitate was observed. Right. So these are the cations that are not present. So these cations are not there in the solution. Then the second experiment is H2S gas is bubbled through the above solution 1. Right. Now this solution 1 is treated with hydrochloric acid. Now we are bubbling H2S fluid. That means that is a group 2 analysis. Right. The reagent of the group 2 analysis is H2S gas dissolved in HCl. Right. So then again no precipitate is observed. That means those 9 cations are not present in this solution. Is it clear? Right. So then second one we can explain that the group 2 cations are not present in the solution. These are the group 2 cations: stannous, stannic, lead, arsenic, antimony, bismuth, copper, cadmium, and mercury. Okay, those cations are not present. Right, then it says the above solution is, yeah, because no precipitate is observed. If there was a precipitate, that means if one of those 9 cations were present in the solution, then they should have given a precipitate. Now no precipitate is observed means those cations are not present. That means once we are treating with the group 2 cation analysis solution, if no precipitate is given, that means these 9 are not present. Is it clear? Right. Right. So then let's move on to the third one, third experiment. The above solution 2 is diluted and bubbled again. Right. Now here we have used concentrated HCl. No? Now the solution is diluted and bubbled again. A yellow precipitate is observed. Right. Now, out of the sulfides, only zinc, cadmium, manganese, and iron sulfides dissolve in dilute HCl. Right. And out of those sulfides, the yellow precipitate is given by cadmium sulfide. Okay. So therefore, when excess H2S is added with dilute HCl, the yellow precipitate is given. That means it shows the presence of cadmium 2+ ions. Right. So we can explain the third one like this. Third observation is explained like this. Only zinc sulfide, cadmium sulfide, manganese sulfide, and iron sulfide dissolves in dilute HCl. Is it clear? Only zinc sulfide, cadmium sulfide, manganese sulfide, and iron sulfide dissolves in dilute HCl. Right. Now here we have added excess H2S with dilute HCl. No? Right. Then you can say when excess H2S is added with dilute HCl, when excess H2S is added with dilute HCl, a yellow precipitate is given. A yellow precipitate is given when excess H2S is added with dilute HCl. A yellow precipitate is given. That is cadmium sulfide. That is cadmium sulfide. Therefore, cadmium 2+ ions are present in the solution. Therefore, cadmium 2+ ions are present in the solution. All right. Then fourth one, excess sodium hydroxide solution is added to the solution 1. White precipitate is observed first and then it was diluted. Sorry, it was dissolved. No? Right. So when adding sodium hydroxide into a solution, if it gives a white precipitate and dissolves, then that substance has to be an amphoteric one. Because the amphoteric ones are given the hydroxide precipitate, and with the excess sodium hydroxide, it gets dissolved. Right. So you can say that this should be an amphoteric hydroxide. This should be an amphoteric hydroxide. Therefore, aluminium, zinc, and beryllium may be present. Aluminium, zinc and beryllium may be present. Okay. Now, don't you question me? What about lead and tin? Lead and tin too are amphoteric, no? But I haven't mentioned over here. Why is that? Because in the experiment 2, we have revealed that there is no lead and tin. Lead and tin is not present in this solution. If it is so, it cannot be there, right? So you better write it with in brackets. You can say that SN2 plus and Pb2 plus ions SN2 plus and Pb2 plus ions, 2 are amphoteric. 2 are amphoteric. But their absence is confirmed in the experiment number 2. But their absence is confirmed in the experiment number 2. Right, then the fifth one, ammonium chloride and ammonium hydroxide were added to the filtrate from the third one. A white precipitate is observed. Right. Now, addition of ammonium chloride and ammonium hydroxide is a group 3 cation analysis. Right. In group 3 analysis, we are identifying 3 cations. What are they? Aluminium, chromium, and iron as their hydroxide. That means they will be precipitated as their hydroxide. Aluminum hydroxide will be giving a white precipitate. Chromium hydroxide will be giving, what's the color?
Green.
No, no way, not orange. Chromium hydroxide, it is a green precipitate. Then ferric hydroxide, FeOH thrice, it is, no, it is yellowish brown color precipitate. So aluminum will give a white color precipitate, chromium will give a green color precipitate, and ferric will give a brown color precipitate. So depending on the color of the precipitate, we can identify the 3 cations from each other. That is a group 3. So once it is treated with ammonium hydroxide and ammonium chloride. Can you remember that? Listen, can you remember? කියද්දි මතක් වෙනවද එහෙම? කියද්දි මතක් කළාද? මතක තියෙනවා. Sanjan? Right. So it has to be like that. Now a white precipitate is observed. So it is confirmed that it has to be aluminum. Right. So we can say that the precipitates of group 3 are, you can explain the observation like this. The precipitates of group 3 are aluminum hydroxide, chromium hydroxide, and ferric hydroxide. Right. Then we can say the white precipitate is aluminum hydroxide. The white precipitate is aluminum hydroxide. Therefore, aluminum ions are, therefore aluminum 3 plus ions are present in the solution. Then finally, we can reduce the two metals that are present in the solution, that are cadmium and aluminium. No? So finally, in a separate point, you can write down. Therefore, the metals A and B are. Therefore, the metals A and B are cadmium and aluminium. Right. So that is the end of that speed test number 2. Right. So if you have written some additional things on papers, attach it to the paper, attach it to this paper and keep it with you. Huh? Right. So that is the end of the cation analysis. Sorry, that's the end of the speed test number 2. And now take that cation and qualitative cation analysis tube to your hand. Now I'm going to explain theory part behind this one, and we can discuss some questions regarding this from the tube that I have given. Right. Now the introduction part is there. Qualitative cation analysis. The composition of relatively complex mixtures of metal ions can be determined using qualitative analysis, a procedure for discovering the identity of metal ions present in the mixture, rather than quantitative information about the amounts. Right. Now, this analysis technique involves the qualitative one only. That's why we call it qualitative cation analysis. That means we can observe only the precipitates and the colors. We can't take a quantitative measure regarding this. That's the thing. Right. Then the procedure used to separate and identify more than 20 common metal cations from a single solution consists of selectively precipitating only a few kinds of metal ions at a time under given sets of conditions. Right. We know that cations can be separated into 5 major groups according to their solubilities of their compounds. First one is the group 1, that is Ag plus, Pb2 plus, and Hg2 plus. Group 1 cations are there. Okay. Then the group 2 cations are these 9. Then the group 3 cations are the aluminium, chromium, and ferric, Fe3 plus. Now here I have mentioned Fe2 plus as well, but there, yes, Fe2 plus and Fe3 plus is also there. Fe2 plus will be precipitated as a green precipitate, but during the reaction process, we are treating with nitric acid. Yes, and we oxidize all the Fe2 plus ions present in the solution into Fe3 plus. Therefore, we do not consider Fe2 plus as a group 2 cation. Huh? Okay, but if you need, if you do not boil with nitric acid, if you do not heat with nitric acid, then Fe2 plus ions 2 will be present. Okay, since it will interfere with the chromium, we eliminate it as chromium. We eliminate it as Fe3 plus ferric ions. Right. Then the group 4, there are 4 cations: cobalt, nickel, cobalt, nickel, manganese, and zinc. Right. So they produce slightly soluble sulfides. Okay. Again, there is a sulfide. Then the group 5 is for the calcium, strontium, and barium cations. Right. There we can identify the calcium, strontium, and barium as their carbonates. Right. Then there's another one, group 6, that is to identify magnesium. Right. And those are the things. That's a summary. Now let's learn about these things one by one. The first one is the chemistry of the precipitation of the group 1 cations. Right. The precipitating reagent of group 1 is a dilute solution of hydrochloric acid. Its concentration is about 6 moles per cubic deciliter, not a very concentrated one. So the precipitating reagent of the group 1 is dilute solution of hydrochloric acid. If you have highlighters, you better highlight the reagent. And the ions precipitated of those of silver, mercury, and lead. And remember that it has to be mercury plus 1, Hg2 plus. That means the oxidation state of mercury is plus 1. So Hg plus 1. So these are the ions. A slight excess of chloride ion is used to reduce the solubility of the precipitates in accordance with the common ion effect. Even so, the solubility of lead chloride is sufficiently high for an appreciable concentration of lead ion to remain in solution. Most of this is precipitated with the group 2 reagent. Okay, so in the group 1, we are precipitating only these 3, right? A slight excess of chloride ion is used to reduce the solubility of the precipitates in accordance with the common ion effect. Even so, the solubility of lead chloride is sufficiently high for an appreciable concentration of lead ion to remain in the solution. That's why the lead 2 ions, most of it will get precipitated in group 2 analysis as well. Is it clear? That means lead 2 plus will be precipitated in group 1 as well as in group 2, because the solubility of lead chloride is high, sufficiently high than the others. Is it clear? Right. So that is group 1 analysis. So the other reagent is dilute hydrochloric acid. I'll write the reagent. Dilute hydrochloric acid. So the group 2 cations, this is the reagent. H2S dissolved in dilute hydrochloric acid. Right. The ions of the group 2 and group 4 are separated by precipitation as their insoluble sulfides. So we precipitate them as their sulfides. Right. The sulfide ion is furnished by the weak electrolyte of gaseous hydrogen sulfide, which is only sparingly soluble in water. So hydrogen sulfide is only sparingly soluble in water. The reactions involved in the precipitation of group 2 cations are as follows. Okay, SN2 plus will precipitate as SNS. Okay, SN4 plus as SNS2. Likewise. Now they have their own colors. So let's write the colors as well. Huh? Right. This one, silver, lead, and mercury, all 3 are white. Now they are in the tube, it is given there, AgCl, Ag2Cl2, and PbCl2. In front of each of it, you can write as white precipitates. Then the other one is SNS, right? SN2 plus, see SN2 plus with H2S gives SNS and 2H plus. So SNS is a brown color precipitate. SNS is a brown color precipitate. Then SNS2 is produced by SN4 plus ions. So SNS2 is a yellow color precipitate. SNS2 is yellow color precipitate. Then lead is there, lead sulfide is black color precipitate. Then we have arsenic. Arsenic sulfide is also yellow in color. Then antimony is there, antimony sulfide is orange in color. Then bismuth sulfide is black in color. Cadmium sulfide is, copper sulfide is there. Copper sulfide is again black in color. Cadmium sulfide is yellow in color. And mercury sulfide is black in color. Okay, so out of those 9 cations, now we have 4 black color precipitates. What are they? Lead, bismuth, copper, and cadmium, copper and mercury. Right, those are black color precipitates. Then there's a brown color precipitate, that is SNS2. Sorry, SNS. Then the yellow color precipitates, SNS2, then arsenic and cadmium. And there's orange color precipitate, that is by antimony. So those are the colors. So you have to remember those colors. Then right, then third one, the chemistry of the precipitation of the group 3 cations. Ksp values of the hydroxides of group 3 cations are very low, and hence they can be precipitated as hydroxide by controlling the concentration of hydroxide ions very low. In this separation, care must be taken not to have the solution of hydrogen sulfide too basic. If the concentration of hydroxide ion is sufficiently high, unwanted precipitation of magnesium hydroxide will take place. To achieve a hydroxide ion concentration of the necessary concentration, an ammonium chloride and ammonia buffer is used. That is to achieve the necessary hydroxide ion concentration. So the equations for the precipitation of the ions of group 3 are given here. So aluminium 3 plus with ammonia, it will give aluminium hydroxide, which is a white color precipitate. Aluminium hydroxide is a white color precipitate. Then chromium will give chromium hydroxide, it is a green color precipitate. Ferric will give ferric hydroxide, it is a brown color precipitate. Yes. No, the reagent is ammonium hydroxide and ammonia chloride. Group 3 cations, the reagent here is ammonium hydroxide and ammonium chloride. Right. So we are using this buffer in order to reduce the hydroxide ion concentration. Can you remember the buffer solutions? So once we add this one, ammonium chloride is a salt, it completely dissolves and it gives a particular ammonia concentration into the media. So this ammonium hydroxide is a weak base. The OH minus ion concentration of this equilibrium, from this equilibrium, will be reduced due to the presence of excess ammonium ions. Therefore, the amount of OH minus ions is less. So only aluminium, chromium, and ferric will be precipitated as their hydroxides. Aluminum hydroxide, which is white in color. chromium hydroxide. It's a green color precipitate. And ferric hydroxide. It's a brown color precipitate. Is it clear? Then the fourth one, that is of the group 4 cations. The ions of the group 4 are precipitated as their sulfides from a basic solution of hydrogen sulfide. Okay, so this is from a basic solution of hydrogen sulfide. In a basic solution, more of the ionization of H2S occurs, and thus the concentration of H2 minus ions increase. It becomes so high that ionic products of the sulfides of group 4 exceed their solubility products and they get precipitated. Right. So the reagent that we use there is H2S dissolved in ammonia. Right. H2S dissolved in ammonium hydroxide solution is used as the reagent. Like this. Right. So there it gives 4 cations. Manganese, cobalt, nickel, and zinc. So they will be precipitated as their sulfides. Okay, now they didn't precipitate as their sulfides in the group 2 because the sulfide ion concentration was not sufficient enough. Due to the common ion effect, this dissolution of the H2S has been minimized because H plus ions are given from the acid. Now here what happens, we are adding ammonium hydroxide. So it will, that means ammonium hydroxide is basic. So it will consume H plus ions and this S2 minus ion concentration will be increased. As a result, they will be precipitated as their reticular sulfides. So manganese will be precipitated as the manganese sulfide. Right. Cobalt as the cobalt sulfide. Nickel as nickel sulfide. Zinc as zinc sulfide. Right. Manganese sulfide is pink in color. It's pink. Cobalt sulfide is black. Nickel sulfide too is black. And zinc sulfide is white. Right. You can mention their colors. Is it clear? Now we have learned about group 4. Then the group 5. The ions of group 5 are precipitated as their carbonates in basic solution. This condition is achieved by removing H2S in the filtrate from the group 4 by boiling and adding ammonium chloride, ammonium hydroxide in excess. Then adding of ammonium carbonate solution will enable the precipitation of the group 5 cations. So as the group 5 cations, we have the calcium, strontium, and barium. They will be precipitated as their carbonates. All are white color precipitates. Then the group 6 cation analysis, there we identify magnesium. If only magnesium 2 plus ions present in a solution, it is easy to identify by a simple test. However, in a mixture of cations, it is difficult to identify, and therefore a specific test with 8-hydroxyquinoline is carried out to identify Mg2 plus by the precipitation, which forms a yellow-green precipitate to O complex. Right. So once we treat a solution that contains Mg2 plus with 8-hydroxyquinoline, it's a chemical reagent, it will give a yellowish green color precipitate. So it may be a complex as well. Then sodium, potassium, ammonium cations do not precipitate with any of the above reagents and usually identified by the flame test. Okay. By the observation of their characteristic colors in the flame. Okay. We will learn about the flame test in another day. I think you can remember. I'll try to do the flame test in the lab, so in the classroom. Yeah, in the classroom. But the thing is, now the chemicals are rare. There are no chemicals in the shops. Yesterday also I searched for some chemicals, but no. The glassware and equipment are there. I have that set, but chemicals are not there. Even potassium permanganate is not there. Yeah. Yes. Condensed powder is there, but I need is the crystals, large ones. Right. Sorry. Acids කොහොමද? We'll see what we can do because we need concentrated hydrochloric acid to do the flame test. බලමු කරන්න පුළුවන් නම් අපි කරමු. Chemicals තිබුණා. Right. So that is the cation analysis. Is it clear now? Now we learned the theory behind the cation analysis. Now take that pink color tube I gave you today. Inorganic chemistry. This one, inorganic chemistry tube 1. There, I have given you some structured essay questions. Structured essay type question, actually it is a kind of short note. Once we complete all these things, you will get a good idea, good knowledge regarding inorganic chemistry. Right, so there, go to the page number 16, the last page. Online students, can you find it? Right. Question number 15. Now it's your time. You can try that question. Find the metals X and Y that made the metal that makes the Z alloy. Why is it difficult? Hmm? මේ දැන් ඉගෙන ගන්න තියෙන එක ඇයි ඔක් කරන්නේ? Hmm. The first time try කරන්න this one? Really?
The precipitation force visible in what dilute HNO3 again root 5
Yeah, the precipitate from 5 is dissolved in hot dilute HNO3 and excess ammonia added.
Conservation of green precipitate is observed first and it's dissolved and the blue solution is observed.
Yeah. Ammonia is added dropwise. So while adding ammonia, it gives the precipitate. Dropwise means we are adding excess. Drop by drop, we are adding in excess. No? So then that precipitate will be dissolved. Right. Let's discuss in another couple. Right. Shall we see it then? Come on, now we are doing a revision. That means now first of all, we have to identify our situation. And so you have to identify that this is your condition. Now we have to learn the theories quickly and apply them to the questions, because in the revision there's no much time to learn theory from A to Z. So you have to refer your theory notes and learn. So usually I will be giving you the parts that I'm going to discuss in the next class. So you better refer to that theory part. Is it clear? Yeah. Oh. Now during these days, we will be discussing inorganic chemistry mainly, right? Because there are some theory students online, they have covered up to inorganic chemistry. So for them, organic is still going on. And Sanjana, if you need the theories from the beginning, now we will be discussing organic chemistry. There are some videos in the YouTube of my YouTube channel as well. You better refer them while you are staying at home. You can refer them, and then you can join the theory discussion on Thursdays. Thursday night we will be discussing the theory, and you can attend to that class. Your brother is attending. Right. So let's go to the question. So it says Z is an alloy made from the metals X and Y. Z alloy is made from the metals X and Y. The following experiments and observations are related with the alloy Z. These are now, there are 5 experiments and 5 observations from them that is regarding the metal, that is regarding the alloy Z. So it is made up of the metals X and Y. Give conclusions for each experiment, then identify the elements X and Y. Give the electronic configuration of X and Y. Those are the questions. So if you identify elements X and Y, it's easy to give the electron configurations. And we have to explain each of these observations, giving conclusions. First one is, Z is reacted with dilute HCl. Okay. A colorful solution, colorless gas is evolved. Okay. Now, dilute HCl means the group 1 cation analysis reagent. Is it clear? Dilute HCl is the group 1 reagent. So if there is a if there's a group 1 cation, there should be a white precipitate. So if there is aluminium, lead, or mercury, there should be a white precipitate. All right. Now here it is not a white precipitate, a colorful solution is given. Is it clear? So colorful solution means there are no group 1 cations, but there are transition elements. Transition elements are there. Usually the transition metals are dissolving in dilute acid to give the colorful solutions. Is it clear? So we can say that. Give conclusions of for each experiment. For the experiment 1, we can say that now it reacts with HCl. So reacts with HCl means it should be a metal which is above hydrogen in the reactivity series. That's why they will react with acids. The metal should be above hydrogen in the reactivity series. Can you remember the reactivity series? Starts with potassium. Here's the hydrogen. So all these metals will react with hydrogen. Right. Then copper, silver, and gold, they will not react. Is it like? So our conclusion has to be a metal above hydrogen in the reactive series should be there. Since the colorful solutions are given, it should be a 3D transition element. Okay. So you have to write your conclusion like that. Right. You can say X and Y are metals above hydrogen in the reactivity series. Since a colorful solution is given, it has to be a transition. It has to be transition element. Then you can say it cannot be lead because lead gives a white precipitate in group 1 cation analysis. All right. Then the second experiment is H2S is sent through the above solution 1. No precipitate is observed. Now, once H2S is added, that means that is group 2 cation analysis. No? So no precipitate means there are no group 2 cations as well, right? Then we can explain that. No group 2 cations are present in the solution. Right, then the above solution 1 is boiled and HNO3 is added. Then ammonia is added in the presence of ammonium chloride. The green precipitate is obtained. Right. Now this is group 3 cation analysis. Now the solution is boiled to remove the excess H2S gas. Excess H2S gas is removed by boiling. Then nitric acid is added to convert any Fe2 plus present into Fe3 plus. Then we are treating it with ammonia in the presence of ammonium chloride. So that is group 3 analysis. It gives a green precipitate. So what is the green precipitate in group 3 analysis? Chromium, no? So therefore we can identify that there is chromium 3 plus ions present. Right. You can say that the green color precipitate is given only by chromium 3 plus ions. The green color precipitate is given only by chromium 3 plus ions in group 3 analysis. Therefore, chromium 3 plus ions are present. Therefore, chromium 3 plus ions are present. Then the fourth one, above precipitate is filtered and the filtrate is sent through H2S. That is group 4 analysis, no? Reacting with H2S in the presence of ammonium hydroxide. A black precipitate is observed. Right. So the black precipitate in group 4 analysis there are two. Those are nickel and cobalt. Yes. So it may be nickel or cobalt. So we can explain it like this. The black precipitate is given only by cobalt and nickel in group 4 analysis. Therefore, either cobalt or nickel 2 plus ions are present. Then the fifth one, now we have identified one metal as chromium. Then the other one has to be either cobalt or nickel, no? Now we have to make sure whether it is cobalt or nickel. So that is done by the fifth experiment. The precipitate from the 4 is dissolved in hot dilute HNO3 and excess ammonia is added dropwise. Okay. The green precipitate is observed first, then it is dissolved and blue solution is observed. Right. So when we are adding ammonia dropwise, nickel will give nickel hydroxide. Cobalt will give cobalt hydroxide. Right. So what's the color of nickel hydroxide? Green. Nickel hydroxide is green in color. Cobalt hydroxide? No, this is blue. So once we are adding excess ammonia, what will happen? This will be converted into cobalt hydroxide COOH twice, that is pink in color, pink color precipitate, and nickel, it will dissolve in excess ammonia to give this complex. This is blue in color. Right, that's the thing. So that means with a small amount of hydroxides, it will give the hydroxide precipitate, and with excess ammonia, it gives the nickel ammonia complex. Cobalt does not, it gives only this. Therefore, it is confirmed that we have nickel. Right, so we can explain that. A green precipitate is given with ammonia. Sorry, nickel gives a green precipitate with ammonia, and it dissolves in excess ammonia to give a blue solution. Okay, it's better if you can write this. Therefore, the presence of nickel 2 plus ions is confirmed. Therefore, the presence of nickel 2 plus ions is confirmed. Right. So those are the conclusions of each experiment. So identify the elements X and Y. So it is chromium and nickel, no? Chromium and nickel. Then C, give the electronic configuration of X and Y. So let's assume that X is chromium and Y is nickel. Right. How do you write the electron configurations? So X is chromium. What is the atomic number of chromium? 24. So then how do you write the electron configuration? 1s2, 2s2, 2p6, 3s2. What? So here the electron configuration of X and Y, that means the electron configurations of metals are being asked. So it is 24. So it is 3s2, 3p6, 4s1, 3d5, right? Not 4s2, 3d4. It's not 4s2, 3d4 like the others, because the half filled configuration is more stable. Therefore, this is an exception of the electron configurations. Then Y is nickel. It's okay. It's correct. 3p6, 3p6, 3d5, 4s1. That's correct. Then nickel. What's the atomic number of nickel? 28. Yes. Then we can write it. OS2, 3d8, or 3d8, OS2. All right. That's how we do it. Right. Now, as I have promised to you last time, we will be revising S block elements. Right. So go to the page number 2 of the tube. Right. Page number 2, question number 2 is there. Right. Explain the reactivity of group 1 elements with water. Right. Now we have to explain the reactivity of group 1 elements with water. Right. Now we know that the group 1 elements, they react vigorously with water. Right. They show vigorous reactions with water, if you can remember. How vigorous are they? Hmm?
Downwards the group, it increases the reactivity.
Right. Now we know that the group 1 metals, they react with water vigorously, and the reactivity increases once we go down the group. No? Right. So once we go down the group, they react explosively, not vigorously. For example, lithium, it has a kind of reactivity with water. It's not vigorous one, but it has a kind of reactivity. Then sodium reacts vigorously. It runs on the surface of water, floating on it, right? Then potassium, the next one, it is more vigorous than sodium, and it reacts giving a purple color flame. Then potassium, then rubidium, it's even more vigorous. Cesium, explosively, right? I will send you a video clip in YouTube. You can watch it and get an idea about how vigorous these reactions are. Okay, so if we consider the group 1 metals, they are lithium, sodium, potassium, rubidium, cesium, and francium is there. We do not consider francium's reaction because it is a radioactive element, right? So there, once we go down the group, the reactivity increases. The reactivity increases once we go down the group. Right. Now, this is the reactivity of group 1 elements with water. So you have to explain the reactivity of group 1 elements with water. You can explain it. You can write down all the metals of group 1 show vigorous reactions with water. Show vigorous reactions with water, and the reactivity increases, once we go down the group. The colorless and odorless gas is released. A colorless and odorless gas is released. So we can write some examples. Let's say sodium. sodium with water, it gives sodium hydroxide and H2. Okay. Let's put the physical states. Aqueous, this is gas, liquid, this is solid. So let's balance this one. It's like this, sodium. If it is potassium, it's the same manner, like this. So you can write some examples over there as well. Okay, so that's how the group 1 metals react with water. Then let's move on to the group 2 metals. Okay, there's a slight change. Now the question is, give the reactions of magnesium with following, with cold water and hot water. Right. Magnesium is there with cold water. Cold water means tap water. There's no reaction. That means once we put a piece of magnesium into the water trough, there's no reaction. But with hot water, right? With hot water, it gives hydrogen gas while forming magnesium hydroxide, which is a white gelatinous precipitate. Right. So with cold water, no reaction. With hot water, you can write down magnesium solid with water, and we heat it. It will give this. Right. So below this one, you can write down magnesium reacts with hot water. Magnesium reacts with hot water, giving a white gelatinous precipitate. A white gelatinous precipitate and a colorless and odorless gas. Then the next one, part C, out of sodium and magnesium, which element is more reactive with water? Okay. That is sodium, no? We know that the reactivity decreases once we go across a period from left to right. That's the theory, right? So you can say sodium is more reactive than magnesium. Sodium is more reactive than magnesium. The theory there is across the period, the reactivity decreases. Right. Then D, how do group 2 elements react with water? Right. Except beryllium and magnesium, all the other group 2 metals, they react with water vigorously. They have some speed, that means they have some sort of reactivity. Not some sort of reactivity, they have vigorous reaction. Right. You can write it like this. Except beryllium and magnesium, all the other group 2 metals, react with cold water vigorously. React with cold water vigorously. Right. Then in a new point, you can write down, new point means within brackets, you can write down the reactivity increases down the group. Right. Then the next question, give the reaction of beryllium with hot water. Beryllium does not react with hot water. Beryllium does not react with cold water, and even with hot water, it has no reaction. But beryllium has a reaction with steam. Huh? Okay. Beryllium with steam, H2O gas, it will give beryllium oxide and H2. It will give beryllium oxide and H2. Right. So that is the next question. How do magnesium and beryllium react with steam? So beryllium gives beryllium oxide and H2, and magnesium to show a similar reaction. Like this. Right. So they will produce the relevant metal oxide and releases H2 gas. This is the metal oxide and it releases H2 gas. Okay, so that is how the group 1 and group 2 metals react with water. Is it clear? Right. Then let's move on to the page number. Page number 7. Turn to the page number 7. Question number 10. Taking sodium as an example, explain the reactions of group 1 elements with air. Right. Now here we have learned the reaction of group 1 elements with water. Now we are going to learn about the group 1 elements with air. Right. So let's learn these reactions. Now we are taking sodium as the example. Sodium with oxygen in air, it will form sodium oxide. Okay. It will form sodium oxide. Now this is not balanced. We have to balance it. 2 sodium, 2 oxygen, 2, 1. So we have to multiply this by 2. Then this will become 4. That is how sodium reacts with oxygen in air. Right. Then in atmosphere, now in air, we have water vapor. Therefore, sodium will react with water vapor. So it will give sodium hydroxide. Is it clear? Okay, we are balanced it. 2 hydrogens, so we have to multiply it by 2. Then it is not balanced. Right, it will give sodium hydroxide and H2 is also there. I forgot it. Okay, so we can balance it like that. So that is again the reaction with water. Sodium reaction with water, even it is steam, it gives the same reaction. Okay. Then in addition to this formation of oxide, there's another reaction, that is the formation of peroxide. With excess oxygen, it produces sodium peroxide. Okay. That too is there. That reaction is also there. Can you remember those reactions? Right. Then we have water vapor. Now this forms sodium oxide. It will react with water. And forms sodium hydroxide. Like this. That sodium oxide too will react with water to form sodium hydroxide. Then there is carbon dioxide in the medium. So sodium oxide will react with carbon dioxide and form sodium carbonate in this manner. Sodium oxide will react with carbon dioxide to form sodium carbonate. And we have the form sodium hydroxide as well. That sodium hydroxide too will react with carbon dioxide to form sodium carbonate and water. like this. It's not balanced. Right. Is it clear? So these are the reactions that we can see if we expose sodium, a piece of sodium into air. Because in the air we have carbon dioxide and water vapor. Now, since sodium has no reaction with nitrogen, we cannot give the reaction of the formation of nitride. But if it is a magnesium, then magnesium will react with atmospheric nitrogen to form magnesium nitride as well. It's okay. Now we are learning about the group 1 metals. So you can write these equations in the space provided. Okay, now this online student asked a question whether is there any formation of sodium hydride with H2? Sodium can react with hydrogen to form sodium hydride as well. But the problem is in the atmosphere, we don't have hydrogen. Yes, H2O is there, H2O gas vapor is there. H2 is not there because H2, it gains the escape velocity. No? It gains the escape velocity easily and it will be escaping from the atmosphere. So that means there's no H2 in the atmosphere. Therefore, there's no any formation of sodium hydride. Is it clear? Right. Right. So then let's move on to the next one. How do potassium, rubidium, and cesium react with air? Right. How do potassium, rubidium, and cesium react with air? So they will show all the reactions that have been shown with sodium. In addition to that, they will form the superoxides. Right? You can say that. In addition to, you can write the answer. In addition to the reactions, shown with sodium, in addition to the reactions shown with sodium, they will form superoxides. That means the potassium, rubidium, and cesium. They will show all these reactions. In addition to that, they will form the relevant superoxide. Like this. These are the reactions. Right. Then, which element of group 1 makes a metal nitride when heated readily with atmospheric N2? Right. I told you that magnesium shows the formation of a nitride with nitrogen. Right. So in the periodic table, there's a diagonal relationship of magnesium with lithium. Therefore, lithium will show reactions that are similar to that of group 2 elements rather than group 1 elements. That's why we haven't discussed about lithium over here. So lithium is the element, lithium with N2, it can form Li3N. So this is the balanced equation. So the question is, which element of group 1 makes the metal nitride when heated with readily with atmospheric N2? That is lithium. The metal is lithium, then you can write the equation. This is how lithium nitride is being formed. Right. Then give the reactions of group 2 elements with air. Okay. Now, for example, if we consider magnesium, it will react with oxygen to give magnesium oxide. In addition to that, with nitrogen, it will give magnesium nitride. Right. Right. You can note down when group 2 elements are heated in air, when group 2 elements are heated in air, they will give the relevant oxide and nitride. Okay, these are the balanced equations. All right. Now we have a mixture of magnesium oxide and magnesium nitride. That means once we take a piece of magnesium ribbon, magnesium usually they are as magnesium ribbons, and we can clean the oxide layer that is formed on this one. Since magnesium is reactive with oxygen, it forms a magnesium oxide layer, right? So we can clean it with the help of a sandpaper, right? Then the shiny appearance is there. Then we hold it to the flame. Yes. We hold it to Bunsen flame. Then it starts ignition. So it will ignite with a bright white flame. Right? Magnesium burns with a bright white flame. Then once it starts ignition, we can place it on a watch glass. Right? So then there will be a white powder that will be formed on this one once it is burned. Right? So that white powder is magnesium oxide plus magnesium nitride. It's a mixture of these. So once this mixture is treated with water, it will give a white gelatinous precipitate, that is MgOH twice, and ammonia gas will be given. Is it clear? So therefore, you will observe the formation of white gelatinous precipitate with a smell of ammonia gas. You will feel the smell of ammonia gas that is released. Is it clear? Right. So that is it. Got it? Right. Right. Then I think that will be enough for the inorganic chemistry part today, and bring that to next time as well. We will be doing this little by little. And since the time is 11:05, let's take a break, because now we have been doing this for 3 hours now. Right. So then let's start the class again at 11:30. Yeah?